Hey guys, how's it going? I hope you enjoyed your spring break. And I just want to remind you that Monday, March 17th, we do not have class for DHD 255. That is because I will be at GDC. And so instead of class, I have this video for this week's lesson. Your homework assignment is to watch the video, follow along, and turn in the project that we create. So today we'll be taking a look at axis-aligned bounding box collision detection, or AABB. Now, so far in this class, we've taken a look at circular collision detection. And in circular collision detection, what you need for your objects is you need their position. And then using their position and the Pythagorean theorem, you can calculate the distance between the two objects, as you guys know. And the way you tell whether or not they're colliding is you take a look at these two objects. You give them both a radius. And if the distance between the two objects is less than their radii, then you know they're colliding. This works very, very well for circles, but it doesn't work for any other shape. So for other shapes, we need completely different approaches. There's AABB, axis-aligned bounding box collision detection. There's oriented bounding box collision detection, and then there's more advanced polygonal collision detection. And we're going to take a look at some of the more advanced ones in a course called Applied Digital Simulation. That's DHD 420. But in this course, we're going to take a look at AABB first and make sure we understand that. Now, the theory for all of these different types of collision detection, except for circular, is pretty much the same. What you want to do is take a look at both objects and see if there exists a gap between the objects. If a gap exists, then they're not colliding. If no gap exists, then they are colliding. Now that's easier said than done. Well, we as humans can take a look at the two objects and very easily see whether or not there's a gap. But it's not that easy to program it. So in any case, I want you to get online and download the starting files for today's assignment. And then once you have those, we're going to extract out of the zip file the project folder and open up the solution. And then we're ready to go. If you want to hit F5, you can take a look at what we have so far. And so far, it's pretty straightforward, pretty simple. You may recognize this if you took SENG 100 with me. Or another course with me last fall. This is the beginning of a one-button runner that I created using some artwork from opengameart.org. Okay. So far, this is very straightforward. I don't have game states in this. I just have our main Game 1 class, and in here, I've got 4 tile BG objects. That is a class that I created, and every update, I'm updating these 4 objects, and every draw, I'm drawing these 4 objects. So very simple and straightforward. If you want to take a look at tile BG, it's pretty simple. As you can tell, there's not a whole lot here. Tile BG is a subclass of the sprite class. And basically, the way tile BG works is every time I go to draw the object, I actually draw it twice. I draw it once in its regular position, and then I draw it once off to the left of itself. So there's 2 copies of it. And what's happening is every update, the background slides to the left, and if it slides off of the screen, then what we do is we bump it back to the right. And this creates the illusion that we have a never-ending assets kind of scrolling by. So we've got the background, we have 3 different backgrounds, and then we have that stone on the bottom. Now this is really effective because these 4 layers are moving at different speeds, creating a sense of parallax, which helps the game to feel 3-dimensional. Okay, so that's all very simple and straightforward. In here you'll notice, of course, I do have the sprite class, which you should be familiar with. We wrote that week 1. And then I also have the sprite sheet class in addition. And of course we'll be using this today. The sprite sheet class, I believe we wrote several weeks back in class. And I've added a couple things to it. I've added a set FPS method, which allows us to set the frames per second that we want this to animate. I just thought that would be easier to abstract into, or refactor rather, into a method and leave frame rate, leave this property private. So I think that's pretty straightforward, pretty simple. Now, the other thing I did was I made it so that when you want to change the animation, you call the set animation method right here, and you pass in the array of rectangles you want to use for the animation. If the array of rectangles that you pass in is not the current array of rectangles, then we set the current array of rectangles equal to what you passed in, and we basically set the animation index to 0. And if you remember, the animation index here is the counter that tells us which frame we're on in this array of rectangles. So whenever we change animations, it's going to start over from the beginning frame of any given animation. Other than that, I think this class is exactly the same as the one we've been using so far. So remember, if you don't remember how this works, feel free to take a look through it. And I think it's pretty straightforward, although I apologize. Again, I do not leave a lot of comments in my code. That is very bad of me, so sorry about that. So to get started, I think we should identify all of the objects that are going to be in this game. In this game, we already have the background defined. That is the clouds, the background vegetation, and then we have the floor that our hero is going to be running on. The only objects we're going to be adding is we're going to be adding our hero, and we're going to be adding some crates that our hero needs to jump over. And that's it. That's everything. The hero needs to be able to detect whether or not it's colliding with the crates, so that we know whether or not to destroy the crates and take points away from the player if they collide with the crates or whatever. Okay. So both of these objects need to have an axis line bounding box defined for them. Okay. And basically, the reason why it's called an axis aligned bounding box is because the top, left, bottom, and right edges of the box are aligned with the X and Y axes. So this makes it very, very simple to determine whether or not there's a gap on the top, the bottom, the left, or the right side of the box. So what I'm going to do is I'm going to create a subclass of sprite sheet that I'll call something like box object. And then I will create a subclass, two subclasses of box object, one called orc, and that'll be our hero player, and another called crate, and that'll be the crates that the hero has to jump over. So in my project, I will add a new class, and I will call the class, like I said, I'll call it box object, capital B and capital O for object, and say add. There we go. I want to, of course, bring in the using statements for X and A, so go copy those and paste them into our box object class file. And we want to say that our box object is a subclass of sprite sheet. And of course, the reason I want to do that is because our hero, the orc, the artwork is based off of a sprite sheet. I should probably show that to you. Here he is. So what we're going to do is we're going to be animating through these 8 different frames, and that'll be him running. Okay. So a box object. Let's go ahead and give it a constructor. So public box object. The superclass of sprite sheet takes a texture. So I'm going to make the box object take a texture 2D, and we're just going to pass that on to the superclass. And now we need to figure out what kinds of properties does our box object need to store. Well, at the end of the day, what we need to know in order to do Aabb collision detection is at all times we need to be able to find the left edge, the right edge, the top edge, and the bottom edge of this box. Now, the left and right edges are going to be an X value from the world origin, and the top and bottom edges of the box are going to be a Y value from the world origin. So you can actually store these as 4 integers or 4 floats. However, I'm going to store them inside a rectangle. So I'm going to declare a rectangle, and I'll call the rectangle Aabb. That's a pretty clever name for our Aabb, our axis line bounding box. Now, in order for us to calculate our AABB, what I'm going to do is, for this game, I'm going to treat the center of the AABB as the, I'm going to treat the position of our object as the center of our AABB. So in order to calculate the left edge, the right edge, bottom edge, top edge, what we need to know is we need to know the width and height of this box, and we need to know the position. Well, Sprite Sheet is a subclass of Sprite, and Sprite has a position property, and we will be calculating the 4 edges for AABB using the width and height of the box. What I actually want to store here is I want to store the half width and I want to store the half height. Half width, half height. And what I will do is I will create an update method. So public virtual void update, and I'll have it take a game time. Okay, and whenever we call update, I'm just going to call a method called calcAABB. So let's create that method. Public void calcAABB, and like I said, when we call update, we'll just call calcAABB. Now, when we're calculating our axis-aligned bounding box, what we need to do is calculate the top left-hand corner of the rectangle and the width and height of the rectangle. Now, if you think about it, for this game, the width and height of the rectangle is never going to change. So we don't really need to calculate that every single update. So what I'll do, though, is I will calculate the top left-hand corner of our rectangle. And what it's going to be, like I said, is it's going to be the position, x value, position.x, minus our half width. And the y value of the top left-hand corner of the rectangle is going to be the y value position minus our half height. Now, I'm casting these as integers because the rectangle struct can only store integers. So the vector2 struct can store floats for x and y, but rectangle cannot. Now, if we wanted to, we could create our own struct or our own class for storing rectangles, but I think in this case, using integers is fine. We're not going to need that extra precision that a floating point number would give us. Now, I'm also going to create another method that we'll use to set the width and height of our bounding box. So I'm going to create a method, public void, and I'll just call it set AABB. And when we call that method, we're going to pass in a width and height. And we'll say AABB, that's our rectangle, dot width equals the width that we pass in, and the height equals the height that we pass in. Now, it's important, since we're using half width and half height to calculate our AABB every update, that we do not forget to set half width and half height. So I'll do exactly that. I will say half width equals the width that you pass in, divide by 2, and half height equals the height you pass in, divide by 2. And there we go. Finally, we need one more method, and what that method needs to do is it needs to be able to detect whether or not this AABB is colliding with another AABB. And this is everything that you need to know about axis-aligned bounding box collision detection. So public, and it will return a Boolean, true if it's colliding and false if it's not colliding. And I'll call the method checkCollide. And in order to check collision, we're going to check whether or not this object collides against another box object that we'll call OBJ. That's short for object. Now, we cannot, with one mathematical comparison, figure out whether or not these two objects are overlapping. Instead, what we can do is see if there's a gap on all 4 sides. And if there's a gap on any of the 4 sides, we know they cannot be colliding. If there's not a gap on any of the 4 sides, then they must be colliding. So what we're going to do is we're going to do 4 comparisons, one for each side. What we'll do is we'll say that if the other object's left edge is less than this object's, if the other object's left edge is greater than this object's right edge, then there must be a gap. And if there's a gap, we're going to return false. There's no collision. And you want to do this for all 4 edges of the box. So I'm just going to do copy and paste. And I'll say if the other object's right edge is less than this object's left edge, then there's no collision. If the other object's top edge is greater than this object's bottom edge, then there's no collision detection. And if the other object's bottom edge is less than this object's top edge, there's no collision detection. Or rather, there's no collision, excuse me. So we check all 4 sides. We return false if there's no collision. If we've checked all 4 sides and there's not a gap on any of the sides, they must be colliding, so we're going to return true. And that's AABB collision detection right there. That's all of it. It's pretty simple. And in fact, it's easier for the computer to do this calculation because there's no square root, there's no complex math going on. All we're doing is we're comparing 4 different numbers. So really, really simple for the computer to calculate. And this is everything we need in our box object class. It's all of the logic we need to have an object calculate its bounding box every update. I'm going to hit F5, make sure I didn't make any errors typing that, and it looks like since it's running, it looks like I don't have any compiler errors. That's a good sign. From here, what I want to do is I want to write the orc class. This is the player class. So I'm going to right click on my project and say add class, and I'll just call it orc with a capital O. We'll zoom in, and I want to copy in the using statements for X and A. And I want to say that my orc is a subclass of box object. Just like that, my orc now has an axis-aligned bounding box. It has collision detection. It has all kinds of great stuff. So from here, let's write our orc class's constructor, public orc, and the superclass takes a texture, but our orc is always going to use the same texture. So I'm just going to pass in the content manager, and then when we call our superclass's constructor, we'll just load up the image then. So I'm going to load up a texture 2D. That texture 2D is called orc, actually lowercase o, orc, and there we go. Visual Studio likes to bump this section down on the next line. I don't typically prefer that, so I'm going to leave that up there. Okay, when we have a player, we need to figure out all of the properties that this player needs. So we know that this is an animated sprite sheet. So what I'm going to do is create a couple arrays of rectangles. One that I'll call animation run, and the other I'll call animation jump. We're going to need to use the keyboard for input. So I'm going to create a keyboard state object that I'll call KS current, and I'll create another keyboard state that I'll call KS previous. Now, we need to know, be able to store and access at any time whether or not the orc is currently running or currently jumping. Those are the orc's 2 states in this game. We could have more states if we want, but those are the only ones we need. Previously, we've defined our enumerations, our structs, our classes outside one another. although technically the C# language does allow you to declare classes inside of other classes, and structures inside of classes, and enumerations inside of classes. This can be kind of confusing, but for today's example, I think it's pretty straightforward. I'm going to create an enumeration called orc state, and it will have two possible states. Our orc is either running or he is jumping. So now that we have that enumeration to work with, let's create a property. So I'm going to create an orc state property called state, and by default I will say that the orc is, I'll say that he's running. Now in order for the orc to move around the screen, we need to have some properties like speed. So I'll give it a speed property, set it to 0, 0. And I think that's pretty good. I'll create another property called ground, and this is the Y position where the ground plane should be. And I've already calculated these numbers. 345 is the Y position for the ground for the orc. Okay. So in the orc's constructor, let's set a couple things. Let's set his initial starting position to 50 for X, and let's set it to the ground for Y, so that he starts out on the left side of the screen on the ground. Let's set the run animation by calling that totally awesome convenience method we wrote called make animation sequence. I have updated it. That's one thing I did. I updated the make animation sequence method to take a width and height. So the width and height of the cells are actually, they're 96 by 96. And then we have to pass in an array of integers, and those integers represent which frames we want in this animation. I actually want all 8 frames in this animation, so I'm just going to type 0 through 7, and we're good to go. The jump animation we'll create the same way, 96 by 96. We'll pass in an array of integers, and I only want one frame in this animation. And if you look at the image, 0, 1, 2, 3, 4, I'll have this be the jump image. So index number 4 is the one we want for the jump. Sweet. Remember I told you we created I created a set frames per second method, and I'll use it to have this animate at 15 frames per second. And in our box object class, remember we created a method called set Aabb. This is where we set the width and height of the bounding box. Now, even though these images are 96 by 96, I do not want the collision box around the orc being 96 by 96. That would give a lot of empty, wasted space around the orc. So I've already gone into Photoshop and I've taken a look at what I actually want the collision box to be around the orc. And it's about 54 pixels wide by 78 pixels tall. So what I'm going to do is say set Aabb, and I'll set it to 54 by 78. Finally, we still have to do one more thing, and that's that we have to set the origin, the center point. Now, if our image is 96 by 96, our origin, if we want it to be right in the center, and that's the way we programmed the Aabb stuff to work, we want its origin to be 48 by 48. 48 for X, 48 for Y. And there we go. We've got a great orc constructor here. Now, there's one thing I want to do so that it doesn't crash when we first run it, and that's I want to call the set animation method that I wrote, and I want to set it to be running, because he's currently running when he spawns. So I think this orc class is going to work great. I'm going to hit F5, And so far, no compiler errors. I do have some warnings, but I can ignore those. And I'm going to go into my game1 class and create a new orc object and see how it looks. So in the game1 class, if you go up to the top where we have the properties defined, we have the 4 tile backgrounds. And now let's create an orc that I will call orc. In the load content method, I will say orc equals a new orc object, and we'll just pass in the content manager there. Okay. Now the orc inherits an update method from the box object class, so we might as well say orc.update, and we pass in the game time for that. And finally, we want to draw the orc. Now it's important, of course, that we draw him after we draw the background so that he's in front of everything. So we say orc.draw, and we pass in the sprite batch. Well, that's something. We see the orc, we see the image has loaded. Yes, but it's not properly cropping and creating the animation effect. Now it's not properly cropping the orc because at no point are we calling the sprite sheet's update animation method. So what we're going to do is we're going to go into our orc class, and we're going to override the update method set in box object. So I'm just going to start by typing the word override, and then I can see all of the methods that I can override, and I'm going to select the update method and hit enter, and it writes the whole method for me, and at the end of the method it already calls the superclass's update method, which is important because the superclass box object, it calculates the Aabb every update. So it's important that I call that update method from this update method. Now, what we can do is we can remember that we want to call update animation every update. And if we do that, cool, we've got an orc and he's running on the ground. Now, what I want to do is I want to start by putting a lot of logic in the update method. And the first thing I'm going to do every update is I'm going to set the current keyboard state. So that will be ksCurrent equals keyboard.getState. And then when I'm doing that, I need to remember that at the end of the update method that I need to set the previous keyboard state so that it's ready for the next update. So set previous keyboard state for next update. We say ksPrevious equals ksCurrent. I will say, I'll leave a note in here for update animation. We'll say animate sprite sheet for that. Call super class update. And I'll just make a note that when we're calling the superclass update here, we're actually calculating Aabb every frame. Okay. Now, the only other thing we need to do in here, I say only, but it's actually a lot of code we have to write, is we have to calculate all of the physics that make up the behavior for our orc. So I'm going to leave a note in here to point out that the next thing we do is we calculate all of the physics for our object. So the physics being, when I press left on the keyboard, he moves left, and when I press right, he moves right. Well, the very basics of the physics say that what we do is we have to add the speed to the position every update. And then remember, it's nice if our speed has some friction to it. So we'll just multiply speed by 0.95f. And then let's get some keyboard input. I'm going to create some convenience methods first, actually. So I'm going to come down here. I'm going to create a method called isPressed. pass in a keyboard key, and I'll say if ks current dot is key down key. Actually, I'm just gonna, sorry about that. I'm just gonna say return ks current is key down key. Then I'm gonna say void, goodness gracious, I'm making so many mistakes. So before I can detect keyboard input, I have to come down here and create some convenience methods. So I'm going to create a method called isPressed. It, of course, returns a Boolean because it's going to tell us whether or not a particular key on the keyboard is pressed. And we will return ks current dot is key down key. And I'll create another one called onPress. I know you guys have seen these before. To know whether or not we just pressed a key, we have to return the result of ks current is key down key and ks current dot is key up key. And I just made a mistake. It's not ks current, it's ks previous. There we go. So this is either going to be true or false. If it's currently pressed down, this is going to be true if it was not pressed down in the previous update. And then we're just going to use the AND operator to compare these two. And then if they're both true, we return a true. And otherwise, we return false. OK, so up here, we say if is pressed keys dot left. What we're going to do is we're going to subtract from our speed x a number. And for now, I'll just use 1. And if our right key is pressed, oh dear, if our right key is pressed, we will add 1. Let's see if that works. I'm going to hit F5, and there we go. We press left and right, our guy moves around, and I think it works pretty well. Except he goes off the screen sometimes. That kind of sucks. So we want to add some clamping. So I'm going to come down here. After we set the position, we're going to clamp the position. So I'll say if position.x is less than 50, we will say position.x equals 50, and don't forget speed.x equals 0. Because if he hits the side of the screen, we should not only clamp his position, but we should also stop his speed. All right, if he hits the right side of the screen at 750, we set the position.x to be 750, and then we set the speed x to be 0 as well. If you hit F5, he should now be clamped to the screen, and that works great. Now, one thing we try to avoid is an over-reliance on constant values. A constant value here would be like the 95, or up here we're actually subtracting 1. And remember, in programming, it'd be nice to be able to change these at once without having to go through and change them in multiple places. I could create a property in this class for the acceleration here, but I'm actually going to do it right here. I'm going to create a float that I'll call force run. And sure, I'll set it equal to 1, and we can always come back and change that later. Now, what I'm going to do is subtract from x force run if the left key is being pressed, and I will add the speed x force run if the right key is pressed. Now, of course, the effect is exactly the same. But we're going to come back to this later and make this so that it performs much better. So of course, the next thing we want to do is we want to be able to add the ability for our hero to jump. So I'm going to say if onPress keys.space, we want our dude to jump. Jumping can be hard to figure out at first. You might think, all right, let's just take speed y and subtract 20 from it. And that works somewhat, woo. Oh dear, there's no gravity. So our guy jumps and he just kind of ends up in the air, which is pretty cool. What I'm going to do is every update I'm going to add gravity. So I'll do it right here before we calculate any input. I will first create a float that I'll call force grav for force gravity. I'll set it equal to 1. And then I will say speed.y plus equal force gravity. Now when I run it, we can, oh dear. Now he just falls right through the ground. We need to add some clamping so that he doesn't fall through the ground. So what I'm going to do is say if position.y is greater than the ground, remember we created that property, it's 345. If position.y is greater than ground, position.y equals ground. And of course, remember to set speed y to 0. Okay, there's our guy. We press space, he jumps, and that's cool. He does this little thing where he jumps and then he lands back on the ground. Now, the system is not perfect for a couple reasons. One, he can double jump all he wants. That's a problem. Secondly, when he's in the air, he still looks like he's running, and we need an improvement there. Okay, so what do we do? Well, what I want to do is I want to go, and when I press space, I want to change his state to reflect the fact that he's jumping. So I'm going to come in here and say state equals orc state dot jump. Okay. Now I'm going to come down here and make it when he, come down here when he hits the ground. I'm going to make it so that when he hits the ground, we set his state back to run. So state equals orc state dot run. Okay. Well, that alone does nothing. He can still double jump. But what I can do is only let him jump if he's currently running. So what I'm going to do is say if the space key is pressed and state equals orc state dot run, then we jump. Now, if you hit F5, you'll notice that he no longer has the ability to double jump, which is good. Now, to change his animation, you could change his animation right in here, so that when you hit the space bar, you set his, you call the set animation method, and you set it to equal his run animation, and his jump animation. But I'm going to do something a little bit different. I'm going to override our superclasses update animation method. So I'm going to say override, and I'm going to find update animation. The update animation method is the method that takes a look at how much time has passed and it goes to the next frame. And if it goes past all of the frames, it jumps back to the beginning. It does some really important stuff. So it's important that we still call our base classes, our superclasses update animation method. But what I want to do is before I call it, I want to take a look at the current state. So I'm going to say if state equals orc state dot run, then I'm going to call this set animation, and I'm going to pass in the run animation. And I'm going to do the same thing for the jump. If the current state is jump, I'm going to then set the animation to jump. Now, notice that this is going to happen every frame, because every frame we're already calling update animation. When we call update animation, it's now going to call this version, which does these two lines of code, and then it calls the original update animation. So this should work really well. Now when he's jumping, he actually looks like he's jumping, and then when he hits the ground, he starts running again. All right, but this jump could be made better. One of the things that makes games really juicy, other than particle effects and screen shake and sound effects, those are all very juicy, but one of the most important ways that games can be juicy is by having very tight controls. You may know from playing other platformers like Mario that when you jump, the longer you hold down the jump button, the higher you jump. And that's not currently the case in this game. And I would love to add that as a feature of this game. So what I'm going to do is I'm going to make it so that if the player's jumping and they still are holding the space key down, we're going to increase their jump speed, or rather we're going to keep adding to their jump speed for about 1/4 of a second or so. So what I need is a timer that keeps track of how much time has passed. So I have to do a couple things. I have to go up to the top and create a timer property. So I'm going to scroll up to the top, and I'm going to create a property. It will be a float. Whoa, that is, my caps lock is on. There we go. A float, and I'll call it jump timer. And by default, it's 0. And the jump timer is going to store how much time has passed in seconds since the jump button has been pressed. Okay, so I'm going to scroll back down to my update. When I press the space key, I'm going to set the jump timer to equal 0.25, which is 1/4 of a second. Okay, and then every update, I'm going to count down until jump timer's back to 0. Okay, so I'm going to say if is pressed keys.space. Okay, so if this space key is currently being pressed, and if the jump timer is greater than 0, we want to do a couple things. We want to keep the player going up, and we want the jump timer to go down. So I'm going to scroll up just a little bit, and I'll explain why in a minute, but I'm going to create a float that keeps track of how many seconds have gone by since the previous update. And I'll call it delta. For delta is a letter that typically means in physics change. So this, I'm using delta here to represent the change in time. And I'll get it by saying game time dot elapsed game time dot total seconds. Now, because we're working at approximately 55-60 frames per second, the delta time is going to be 0.016 seconds, I believe, somewhere in there. So the number is going to be pretty small. Next thing I want to do is I want to create a force for jump, and this is the force that we're going to apply every update that the jump key is still being pressed. Okay, so let's scroll back down a little bit, and I will say speed.y minus equal force jump, and then we will say jump timer minus equal delta. Okay, so I'm going to hit F5, and you'll notice now that if you tap, he jumps a little, and if you hold, he should jump a lot. And you could play around with some of these numbers to get the exact effect that you're looking for. One of the things I want to do is I want to decrease the initial jump amount. So initially we had his speed go up 20 when you press jump. I'm going to have it go up 10. And then, there you go. I think the effect is really obvious. If I tap the space bar, he just does a tiny little hop. And if I hold it, he does a much larger jump. Okay, so why am I creating these 3 different variables? Well, it's important that as you develop games, you consider the fact that the frames per second is not always consistent. Remember, the frames per second is going to fluctuate based on the individual computer, what other applications are running, all those kinds of things. So what we need to do is we need to set things like force run, force gravity, force jump, these forces that get applied every update. We need to apply force equal or proportional to how much time has gone by since the previous update. This can sound kind of confusing, but the easiest way to do it is to take this delta number and multiply it by some force constant. Okay. Now, we don't want to necessarily say just 1 times delta, because now, since delta is going to be about 1/60th of a second, hopefully, our force here is going to be 1/60th of 1, which is just 1/60th. So that's much smaller. If you want to have about the same force, say 60 times delta, since we're trying to be locked at about 60 frames per second. Or rather, that's our goal. That's what the game is running at on my computer, but it's not the goal. It's not what it'll be running at on every computer. So notice that doing that really has no effect on the game on my computer. But like I said, if the frame rate ever drops, it'll still continue to run smoothly even though there's fewer frames per second. Okay, one of the reasons why his jump is a little funny is because if we scroll down a little bit right here, we're applying friction to both his X speed and his Y speed. And for some games this is appropriate, and arguably you could argue that it's appropriate here as well. But for this game, I don't really need it. All I'm going to do is I'm going to not apply friction to Y, and I'm only going to apply the 5% friction here to the X speed. Okay, now if I do that, his left-right movement should be exactly the same as it was a moment ago, and his jump is a little less sluggish, and he doesn't tend to hit a terminal velocity as he falls, so he picks up speed a little bit more. And also because of this, he jumps a little bit higher now. Notice that if I tap this space bar, he just jumps a little, but if I hold it down, he jumps a lot, like twice as high. So this is a pretty good jump arc. It's not bad for this game. Now, there's an improvement. You won't notice it much in this game, but it's important that if the player lets go of the space bar as they're jumping, we immediately set jump timer to 0. Otherwise, they could potentially look like they're getting a double jump. So I'm going to say if the space bar isn't pressed, then jump timer equals 0. So remember, whenever we first press the space bar, we're resetting jump timer to 1/4 of a second, then it counts down, and as it's counting down, if the space bar is still being pressed, we're going to keep pushing up on the player so that they jump higher. So I think this is pretty good. This is everything that we need to do for the Orc class, so we are completely done with this guy. Next up, we just need to create the crates. So I'm going to go into the Solution Explorer, right-click on my project, and say Add Class. I'm going to add a class called Crate with a capital C. Zoom in here a little bit. And of course, copy over the using statements that will pull in the X and A namespaces. Let's declare that the crate is in fact a subclass of box object. Let's create a constructor for crate. Remember, box object requires a texture 2D. So all of the crates use the same texture in this game. I'm going to just pass in the content manager, and when we create a crate, we will call the base constructor. We will load up a texture 2D, and that texture will be crate, and there is our constructor. I'm going to hit F5 real quick, just make sure no compiler errors. Hey, good. The crate class is really simple. What I'm going to do is create an override for the update method. So I'm going to override update. And what I want to have happen is I want the crate to be moving to the left. So I'm going to calculate a speed, and I will then, of course, say position.x minus equals speed. And that's pretty much all the logic we need for a crate. So what I'm going to do is I'm going to test this now. I'm going to jump over to my game class, and I'm going to need a game that can store more than one crate at a time. So of course we create a list that can store crates that we will call crates. We'll say make it a new list. We'll instantiate it. Okay. And what I need is I need to be able for the game to create the crates dynamically. So I'm not going to create them in the load content method. I'm going to create them as the game runs. So I have to create them in the update method. Now I can't create them every update because that would be insanity. That would be 60 crates created every second, which is far too many. So what I need to do is I need to create a timer that tracks how much time has gone by since I've created the last crate. So I'm going to scroll up to the top and create a property that I will call timer crate, set it equal to 0. It's a float because we're tracking seconds. We're trying to do everything so it's based off of time. And we will say every single update, we'll say timer, oops, oh my goodness, I'm having problems typing today. Timer crate minus equal game time dot elapsed game time dot total seconds. And then we'll say, all right, if timer crate is less than 0, then we will create a new crate. So we will say crates.add, and we will pass in a new crate, just like so. And when we create that crate, we need to set the timer. If we want to do 1 second between each crate, we just set it to 1. And we're going to keep it like that for now, see how it works. Now, we have to update the crates if we want them to move. So I'm going to come in here, and after I update the orc, I'm going to say for int I equals crates dot count minus 1. Run the loop as long as I is greater than or equal to 0, and subtract 1 from I every update. What I'm doing here is I'm creating a loop that's going to count down through the list instead of up through the list. And that's important so that we don't have a memory leak when we remove objects. So, or not a memory leak, rather a glitch as we're updating the objects. We need to make sure we don't skip updating any of them. So I'm going to come in here and say crates I dot update game time. Sweet. And then I'm going to go down to the draw method, and we're going to draw all of the crates. So I'm going to say for each crate C in crates C dot draw, and we pass in the sprite batch object. Okay, hit F5. We are now spawning crates. You can see them in the upper left-hand corner, and they are moving left after they spawn. Now, they're in the upper left-hand corner, of course, because their position defaults to 0, 0. So to fix this, go to the crate constructor, and let's set the position to where we actually want them to start. And this could be some trial and error. You could guess this number. But we want them to start off the left-hand side of the screen. The screen is 800 pixels wide, so we're going to use 900. And then I've already calculated the number. They're going to be at about 336. I'm going to hit F5, and you'll see that the crates are created off the left-hand side of the screen, and they slide in on the left. However, they should probably be sliding the same speed that the ground is going by, and they are not. Now, in order to fix this, what you can do is you can go take a look at what speed I made the ground slide by. The tile BG's update method takes game time and it takes a speed, okay? And it's important to know that I'm doing what I'm doing. What I'm doing, of course, is taking the number of seconds that have gone by since the previous update, and I'm multiplying it by that speed that's passed in, okay? So the speed that I'm passing in for the ground is 500. What that actually means is not that it's moving 500 pixels per update, but since we're multiplying it by the number of seconds that have gone by, it means that it's moving 500 pixels per second in the end. And that's why we use seconds instead of updates, because those are reliable, whereas updates are not. So I'm going to go into the crate class, And for speed, I want it to move at 500 pixels, not per update, but per second. So we multiply that by the number of seconds that have gone by. So game time, elapsed game time, total seconds. Now if we hit F5, hey, look at that. The crates look like they're sitting on the ground because they're moving the same speed as the ground. This works great. There are a couple problems. First problem being that the crates, even though they go off the left-hand side of the screen, they are not being removed from the game. We have a memory leak because more and more crates keep getting created. If you've taken my classes in the past, you may know that I just throw a Boolean in here that keeps track of the state to whether or not the object is dead. Dead can kind of be a little bit confusing, so I'm going to suggest that we use a Boolean called dispose. Okay? When we're ready to dispose of this object, dispose meaning to remove it from the game, we're going to set dispose to true. Otherwise, it's false. And of course, I got to make that public. So I've got a property, it's a Boolean, it's called dispose, set it equal to false. And what in the crates update, we're going to take a look and see whether or not it has gone off the left-hand side of the screen. Now remember, we don't necessarily just want to say if position.x is less than 0, dispose equals true. We don't necessarily want this because remember the position of the crate is actually going to be in the center of the crate. So if we remove them when its position has just moved beyond 0, then the crate will still be half on the screen. We'll take a look at what I mean here. Let's go out to the game1 class. And in this loop where we're updating all of the crates, we're going to take a look at each crate and see whether or not it's dead. So I'm going to say if crates number I, if that crate's dispose property is set to true, then we are going to say crates.remove at, and we're going to remove the crate at position I in the array. So now when we run it, the crates will slide to the left, and then they disappear when their x position is less than 0. But you can see that the image is still on the screen when the x position is less than 0, so they appear to be popping out of existence. Now this is good because we know that they're being removed from the game. This is bad because it looks like crap. So what do we want to do? Well, let's go into the crate class. Instead of saying if its position.x is less than 0, we want to know whether or not the right edge of the crate is less than 0. Now, remember, we have this property called Aabb, and I might need to go into box object and make that property protected so that I can access it in the crate class. So I made Aabb protected. In the crate class now, I can actually say if the right edge of the box is less than 0, then dispose of it. And this should work great, but we've actually forgotten a step because if you look, they still disappear while they're on the screen. The step that we've forgotten is we've forgotten to set up the Aabb with the width and height of the box. Remember, there's a property called setAabb where we pass in the width and height. I'm going to pass in 96 and 96 because that is the width and height of the image, and I actually want that to also be the width and height of the collision box. Now, when the right-hand side of the collision box goes off the screen, it disappears, and the entire image is off the screen when that happens, so you can't see it disappearing. Hurrah! Okay, the other thing that we need to do now is we need to add collision detection. Now, we've already written all of the logic we need for collision detection, all of it. And in fact, it's in the box object class. It's this method right here, check collide. That's our collision detection. All we have to do is call this method. So go to the game1 class, and what we're going to do is for each crate, we're going to see whether or not it's colliding with the orc. Now, we're already looping through all of the crates, so let's just do that collision detection inside of this loop. After we update the crates, but before we remove the crate, if it's dead, we will say if crates number I dot check collide, and then we'll pass in the orc object. If that returns true, then there's a collision. If there's a collision, we can remove the crate by setting its dispose property to true. Okay. Now this would also be an appropriate place for you to add particle effects or screen shake or sound effects. But let's see if it works. Hey, sure enough it does. When the right edge of the orc passes into the left edge of the box, it disappears. But notice we can hop on the top of the box, or we could even try hitting the right side of the box. That might be a challenge. Boom, goes the dynamite. Well, I think this is everything I wanted to show you guys today. So for your homework assignment, I was going to make you create your own game with axis aligned bounding box, but we're going to be doing that when I return from GDC anyway. So I think for this week's homework assignment, I just want you to create this right here. So if you followed along in the video and it's working fine, then add some comments and upload it to Blackboard, and you'll get your points for this week's assignment. I think that's everything I wanted to cover. Thanks guys for watching, and if you have any questions, of course, please shoot me an email. All right, take care.